In this chapter, you confront the quadratic equations. And a quadratic equation is a second-degree polynomial equation. For example, 2x squared minus 3 equals to negative 5x is a polynomial equation because the terms are all, if they're x's, they have integer powers. And the highest power is 2, right there. So that makes it a second-degree equation. And second-degree equations have become to be known as quadratic. So it's the next step up from the linear equations with which we began this course. And there are several methods of solving these. You've probably seen this if you looked over my chapter 6.0 stuff, my review of factoring. I do cover solving by factoring, but I want to review it again for this chapter just to make sure everybody has it. Alright, so first thing I'm going to do is to reorganize the equation into descending powers. And so I do that by adding 5x to both sides in order to sort of bring the 5x over to the left side. So we end up with 2x squared plus 5x minus 3 equals to 0. And notice I says writing it in descending powers. That means we began with the squared term, the x squared term, and then the first power term, just the x term, is also called the linear term. And here's the non-zero constant. It equals 0. Well, it turns out that our technique of solving this, when possible, we want to try to solve it by factoring. And so can we factor this polynomial? Of course, I made up the problem, so it should factor. And let's see. In order to get 2x squared, I need 2x times x. So there's 2x squared. 3, there's only one way to break up 3, 1 times 3. So the question is, where does the 3 go and where does the 1 go? Let me try this one first. If I put the 3 here and the 1 there, then in order to get plus 5x, I need plus 3x and plus 2x. So let's see if this works. I have 2x squared plus 2x plus 3x is 5x. That's good. Plus 3. Whoops. Doesn't work, does it? So it doesn't factor because I don't get a negative 3 when I multiply it back. Well, that tells us that we should probably change the 3 and 1 position. So I'll switch those. And we also need a negative sign, or at least one negative sign in order to produce a negative. Alright, so what would it be? It was 1 here and 3 there. It equals to 0. Alright, so this gives me 6x. And I want a plus 6x and a minus 1x. So let's check that. Got 2x squared. 6x minus x is 5x. And negative 3. So the factoring checks out. And here we come to the small miracle in all this. Why are we factoring? We're multiplying two numbers together and we're getting 0. And what happens when you multiply two numbers together to get 0? Doesn't that mean that at least one of those numbers has to be 0? Have you ever seen two numbers multiplied together equals 0, and both these numbers were not 0? No, I haven't either. It's not possible in a real number system. It is possible to see something like that in other kinds of algebra systems, but not in our ordinary real number system. So the what we call the zero product property means that when two numbers multiply together, a times b equals to 0, then a equals to 0 or b equals to 0. So again, zero product property. When you multiply two numbers together to get 0, then the first one is 0 or the second one is 0. They could both be 0 also. Alright, so that's what we're going to take advantage of here. When this equals to 0, then either this number, think of this 2x minus 1 as a number, either 2x minus 1